Mr. Hassoumi, for your kind presentation and summary of the fantastic opportunities for mining investment in the Republic of Niger. And no doubt we'll be hearing more about that later when Dan Major from GoviEx, who's a truly exciting mining company, will be delivering his presentation to you and will be reflective of really the excellent geology of Niger. It's my pleasure now to welcome the two co-presenters from SRK. They are Oliver Bailey, Senior Exploration Geologist, and Ben Lepley, Senior Consultant, Resource Geology, who will be giving a presentation on adaptation and integration and why that's so important and exploration in mine development. So please join me in welcoming them to give their presentation.
Okay, Honourable Ministers and ladies and gentlemen, it's a pleasure for SRK to be sponsoring this event and bringing stakeholders together to discuss and focus on Africa and the Middle East. We hope that mining can be an increasing enabler and springboard for development within this region, and we hope to support mining within the region itself. I'm going to speak today with my colleague Ben Lepley about adaptation and integration within the exploration and mining development. But before I do that, I'll just give you a brief introduction into SRK itself. SRK is a global mining consultancy. It's based across the world. We have 47 offices in different countries. What sets us apart in many ways is that we're totally independent. We're employee-owned, and the mining industry and the investment sector realise this, and it's a real advantage in all our reports and deliverables, knowing that we are fully independent. The group itself combines many disciplines, right from the exploration, very early exploration stages, all the way through mining development to mine construction, environmental and social responsibility, all the way through to mine closure and rehabilitation. So we have experts in our offices in all of these disciplines, and we form an integrated service bringing in those disciplines as required. I thought I'd just mention quickly that give an idea of the risk involved in exploration and development projects itself. This figure just gives an idea of the amount of projects that go from a very early exploration stage through to resources, beyond to feasibility, and finally into developing a large-scale international mine. As you can see, there's a huge amount of risk starting off with a large number of exploration projects, and these get reduced rapidly. And it's really, I'm sure that a lot of people at this conference today and tomorrow will be talking about the risks involved. And if you're looking from a government perspective, you're really reducing risk by providing open source data to explorers and junior miners who can focus on the most prospective areas in your respective countries. And if you're a miner or explorer, then you're wanting to put through the best exploration methods and techniques to develop those projects as quickly as possible and move them up that risk curve. SRK itself reduces risks in two main ways. The first is by putting together exploration programs specifically tailored for the specific project, using the latest technology and bringing that together to reduce the project risk, the technical project risk. The second is that we've got the unique ability of being able to bring in-house experts that are usually involved in later stages of a project during feasibility and other studies. We can bring those people in right up at the early stages of exploration if required, and really have a look at the fatal flaws fatal flaw analysis of any projects early on, and input from some of these other disciplines can really move a project along a lot quicker and reduce the risk at an early stage. So basically, what do we mean by integration? Well, integration is bringing multiple data types and sources together, doing that with different exploration techniques and technical data, but also bringing in disciplines as I've just discussed. Adaptation is really important in any early stage project, and as an exploration geologist, I know that my results from today are going to affect my exploration program for tomorrow, and it's really about adapting to the data that you're creating, that you're producing, and taking that project along the shortest and quickest path to development. So why do we integrate, and why is it beneficial for a project? Each project is very unique, and therefore there's no magic formula or roadmap that works for them all. It's really important to have a look at those fatal flaws early on in a project. As exploration geologists, we're often very focused and get excited about the mineralisation in the ground, and off we go and charging to put money in, to explore, to develop, and to move it along that way. And it's really important that you take a step back and you have a look at, okay, what are the other issues that may be involved in this project, and address those as early as possible, and really reduce that non-technical geological risk. Integration also streamlines the process. It can reduce timeframes significantly, and it also leads to creating data sets at the very outset that can be used by later disciplines, and reducing the amount of re-drilling or doing things more than once. So it's important to reduce risk as quickly as possible, and the main benefit to our clients is it saves money going forward. So I'm just going to run through an example of an orogenic gold deposit in Saudi Arabia that we worked on recently. Just touching on a couple of disciplines that we brought in that are usually later stage, which really helped the project progress. The client was had very short timeframes in mind, and we took the project from greenfield exploration right through to conceptual open pit and underground design in less than 12 months. We started off by bringing in multispectral imagery and putting geologists on the ground doing mapping, and also bringing in geophysics. And this defined about 100 targets within the exploration area. These were ranked, brought down to about 25 where we did extra sampling, and this led to a very small number of projects that we decided to drill. On initial drilling, we really realised that this project was quite a small, narrow vein, low tonnage but high grade deposit, and this limited tonnage may mean that it wasn't feasible to continue with the project and establish a processing plant on site. What we did was have a quick review, high-level review of the logistics and infrastructure available. The mining company itself had a project about 100 kilometers away that it was decided to see if the processing plant for this project, which was for a different commodity, could be adjusted to accept this feed along with its own. So to understand that and to see if it was feasible, we brought in a metallurgist to do a high-level review, and his input basically confirmed that yes, we could go ahead with the project, and that fed back into the drilling phase and gave us the confidence to continue drilling, and the client the confidence to continue with the project. So from the mapping itself and from the drilling and assay results, we created a 3D geological model, which was updated after every drill hole. From this model, we could see that there's the opportunity to move a long strike along this vein system, or concentrate on the ore shoots that were defined near surface to extend these at depth. Now there's a limited budget for the exploration here, a limited number of holes, So what we did was we had to decide whether it was better to try and drill along strike in potentially low-grade areas, or prioritise the drilling at depth underground, at the depth, and see if underground mining was feasible. In order to decide on this, we could bring in and call on the geotech and mine design guys from the SRK Consulting Office, and because we collected geotechnical data from the outset in the exploration drilling, that could feed into the model, and conceptually this could support a small underground operation. That gave us the confidence to say, right, in the limited drilling we've got left, we're going to prioritise drilling in known shoots at depth, and this actually more than doubled the resources that were finally calculated for the deposit. So just to summarise, basically we took this greenfield project through to MRE and conceptual pit design in less than 12 months. And if it wasn't for bringing in infrastructure and metallurgy, and then latterly geotechnical and mine planning disciplines, then the project itself would have been a lot smaller, and it may have decided actually not to go ahead at earlier stages. I'm just going to very briefly go through another example of a much larger scale deposit. This is the Belinga iron ore deposit in Gabon. SRK were engaged to carry out early stage exploration leading to mineral resource estimation of the project. Even before we got in country, we identified that because of the large scale nature of the commodity of bulk mining, it would be affecting a large area. The mining would go on for many years. It was really clear to us that we needed to get in there with CSR from the outset, and not just bring that in when we had troubles, but really to bring the community along with the project, but also to educate the community on what stage the project was at. This is an exploration project. There's not going to be a large mine here straight away, and manage those expectations going forward to avoid problems as the project progresses. So that's sort of where we can bring disciplines into the earlier stage exploration side of the projects. I'm just going to hand over to my colleague Ben Lepley, who will take you through some of the more downstream integration that we do at SRK.
Thank you very much, everyone, for having us here again. So I'm a resource geologist at the SRK Consulting arm, the sister company to the SRK Exploration. So I deal with more of the down the line development of the project. So as we develop the project, it goes into feasibility study through to production. Obviously, a lot more data is acquired, a lot more drilling, a lot more sampling, a lot more technical disciplines require input. And so as we go forward, the development plan becomes a bit more refined, there's more detail, but also becomes less flexible. So we need to be able to adapt and adjust our plans, and this is really driven by the increasing production, throughput, recovery, and ultimately, dollars at the end of the day. So integration of the different disciplines. When we talk about disciplines, maybe hydrogeology, geochemistry, tailings, geometallurgy, a whole group of disciplines that all need to feed in together to generate feasibility studies and develop mines. And this becomes absolutely critical that they talk to each other. And once we get into the operational environment, operational improvements are only really made by detailed disciplines talking together. And the idea really that we want to optimize the efficiency of the mines, maximize the profit, obviously, but at the same time not compromising the safety and the social and environmental impact. So I've got a few more generic examples which are very applicable to Africa and Arab mining situations, but where integration of technical disciplines has really helped save money and speed up the project. So what we like to call piggybacking of data, where for example, we're doing a drilling campaign, and drill holes are being used to collect samples for exploration data to gain information about the grade, about the quality of the ore. These core drill holes can also be used for many other applications, and the further along, the earlier you bring these into play, the more data you require, and as Ollie was talking about, reducing the risk earlier on. So other disciplines that can gain from this, geotechnical information, so about the stability of the mine, the rock quality, how it's going to perform during mining and blasting, crushing, hydrogeology, the movement of groundwater, which could be critical, especially in very wet environments such as West Africa and the tropical regions. But also other things such as metallurgical sampling. So one core drill hole could be used for all these different disciplines at the same time, and it's often the case that the exploration geos get very excited, plug a few holes in, and it's all very rushed, and there's geological data taken. But if you step back before you do the drilling, you could also plan these holes to collect this other information and integrate it together. So, why are we doing this? Really, the benefits of doing this really are the reduction in money, but reduction in costs. So fewer discipline-specific holes. So it's often the case that maybe the metallurgist comes along later and says, "Oh, I need some samples for my processing test work," whereas actually they could have brought that into play earlier on by using the exploration drill holes. The same with the geotechnical information and hydrogeology. We're gaining knowledge and more of a holistic understanding of the issues at an earlier stage by collecting this information, all feeding together for technical studies to develop the mine. And also time. So the more data you capture up front, the less you have to capture down the line, which speeds up the development of the project. And they need not be expensive, and even simple data collection for early stage exploration can be very useful down the line. An example of how the different disciplines should be using the same data sets really is a geological modelling. So I'm a resource geologist, so I'll create a 3D model to generate resource and reserve estimations. But this same model, which is basically just a 3D snapshot of the ground underneath our feet, can be used for all these different disciplines. So geotechnical disciplines, how the different lithologies perform, if there's weather zones, how they perform geotechnically, metallurgy processing, so identifying different ore types and how they respond to different processing types. Mine planning, obviously, where the actual mine is going to go, the elevation, how the pit is going to look in the ground, and stripping ratios, etc. Hydrogeology, so this model in the background here, got some dipping aquifers, where the water is actually going to be very important, and finding structures that water can be focused along. And then also down the line, disciplines such as tailings and management of acid mine drainage, so finding out volumes and tonnages of material that could be acid generating. So just one snapshot here of how you can integrate a lot of disciplines into one place, and they should be using this all together and integrating. A very, very different side of things, but looking further down the line, how an example here of a bauxite project in Guinea recently, where early on in the project development, before the feasibility study, ESIA, impact assessment was undertaken and identified areas of potential chimpanzee habitats. This was flagged early on, and a biodiversity study undertaken and identified key areas within the license area where there was a high sensitivity to destroying chimpanzee habitat. And this was actually then used and fed back in to the mining development, and how they we're going to actually develop the infrastructure for the mine. So avoid any potential conflict down the line with environmental groups, for example. And this is really demonstrating good CSR, identifying the risks up front and adjusting your mine plan to avoid future conflict and issues. An operational example here of potentially where the plant recovery is decreasing, for example, and how the different disciplines are integrating and adapting at the same time. So starting at the top left, if the plant has seen a decrease in recovery, what do we then do? We go back to the geological data, have a look at the model. We might identify that actually there's a different ore type there that's not responding to the processing as effectively. We might then go update the geological model and estimate the tonnage and grade and location of this material, maybe undertake some more test work, adjust the mine plan, adjust the processing flow sheet with the ultimate aim of improving profit, improving recovery and improving profit. So lots of different disciplines involved here, financial modelers, metallurgists, geologists, mine planners, all working together, integrating and adapting to a situation that was difficult for the mine. So as a conclusion then, it's all about reducing risk, really, as Ollie said, getting in at an earlier stage in the project and collecting data up front on the left-hand side of the graph here. So there's a lot going on here, and apologies, it's a bit small, but on the left-hand side we have exploration targets, then we go to the right-hand side to mineral resources, ore reserves, and you can see the curve. We have scoping studies followed by feasibility studies into design, engineering and production. And as you go towards the right-hand side, your risk reduces, your project value increases, and the number of projects right at the bottom, as Ollie said, significantly reduces as well. But the important thing is, if we bring in integration of these different disciplines, we can hopefully reduce the risk quicker and help bring the mine into production quicker and more efficiently. So that's all we had to say. Thank you very much for listening, and thank you for the opportunity to speak to you today.